Hello students, in Science 1 we will revise chapter 11 Reflection of Light, drawing the reflected rays in spherical mirrors. In the given figure as shown, Mn is a spherical mirror and ray AQ is the incident ray, that is, it is incident on the mirror. CQ is the radius and therefore is perpendicular to the mirror at Q. Thus angle AQC is the angle of incidence. According to the laws of reflection, the angle of incidence, which is represented by small I, and the angle of reflection, which is represented by small r, are of the same measure. Thus, while drawing the reflected ray QB, angle CQB must be equal to the angle AQC. Rules for drawing ray diagrams in spherical mirrors. Rule 1. If an incident ray is parallel to the principal axis of a spherical mirror, then the reflected ray passes through the principal focus. Rule 2. If an incident ray passes through the principal focus of a spherical mirror, then the reflected ray is parallel to the principal axis. Rule 3. If an incident ray passes through the center of curvature of a spherical mirror, then the reflected ray traces the same path back. Images formed by concave mirrors. The images formed by concave mirrors depends upon the position of the object from the mirror. If the object is placed between the pole and focus, then the position of the image is behind the mirror, the nature of the image is erect and virtual, and the size of the image is magnified. If the object is placed at the focus, then the position of the image is at infinity, the nature of the image is inverted and real, and the size of the image is very large. If the object is placed between the focus and the center of curvature, then the image is formed beyond the center of curvature, the nature of the image is inverted and real, and the size of the image is magnified. If the object is placed at the center of curvature, then the position of the image is at the center of curvature, and the nature of the image is inverted, real, and the size of the image is same as the size of the object. If the object is placed beyond the center of curvature, then the image is formed between the center of curvature and the focus. The nature of the image is inverted and real, and the size of the image is diminished. If the object is placed at a very large infinite distance, then the image formed is at the focus. The nature of the image is inverted and real, and the size of the image is a point size image. Ray diagrams for images formed in concave mirrors. If the object is placed between the pole and the principal focus, the image is formed behind the mirror, it is erect and virtual, and it is magnified. In the second case, if the object is placed at the focus of a mirror, then the image is formed at infinity, it is inverted and real and very large. In the third case, if the object is placed between the center of curvature and the focus, then the image is formed beyond the center of curvature, it is inverted and real and magnified. In the fourth case, if the object is placed at the center of curvature, then the position of the image is also at the center of curvature, it is inverted, real, and of the same size as that of the object. In the fifth case, if the object is placed beyond the center of curvature, then the image is formed between the center of curvature and the principal focus. It is inverted, it is real, and it is diminished. That is, it is very small. And finally, if the object is placed at infinity, that is at a very large infinite distance, then the image is formed at the focus, it is inverted, real, and a point size image. Let us observe the ray diagram for images formed in convex mirrors. In the first case, if the object is placed at infinity, then the image is formed at the principal focus. It is virtual, erect, and extremely diminished, that is highly diminished. And in the second case, if the object is placed between infinity and the pole, that is at a finite distance, then the position of the image so formed is between the principal focus and the pole. Here A dash B dash is the image formed. It is virtual, erect, and diminished. Let us revise the uses of concave and convex mirrors. Uses of concave mirrors. A concave mirror is also known as a converging or focusing mirror. It is used in barber shops. It is used for shaving. It is used in dental hospitals. If the object is placed between the pole and focus of the mirror, an erect, virtual, and magnified image is obtained. A concave mirror is used in torches and headlamps of vehicles. The source of light is kept at the focus of the mirror, thus a parallel beam of light is obtained. It is used in floodlights. The source of light is placed a little beyond the center of curvature of the mirror. This gives a bright beam of light. It is also used in various equipments which uses solar energy, that is, it is used in solar devices. The sun rays reflected by a concave mirror comes together in the focal plane. Uses of convex mirrors. A convex mirror is also known as a diverging or dispersing mirror. It is used on the sides of cars. Big convex mirrors are fitted in the hallways of buildings including stores or shops, schools, hospitals, hotels, and apartment buildings. Convex mirrors are used in driveways, roads, and alleys to provide safety to all the bikers and motorists at curves and turns and other places where there is a lack of visibility. Conventions are used for reflection from a spherical mirror. As per the Cartesian sign convention, the pole of the mirror is considered as the origin and the principal axis is taken as the x-axis of the frame of reference. As observed in the figure, P is the pole and the principal axis is the x-axis. Given below are the sign conventions. The object is always kept on the left-hand side of the mirror. Measure all distances parallel to the principal axis from the pole of the mirror. All distances measured towards the right of the mirror or the right of the pole are positive, while those measured towards the left are known to be negative. Distances measured vertically upwards from the principal axis are taken to be positive, and distances measured vertically downwards from the principal axis are taken to be negative. The focal length of a concave mirror is negative, while that of a convex mirror is positive. What is mirror formula? The relationship between object distance, image distance, and focal length is known as the mirror equation. It is also known as a mirror formula. We get the correct values of distances by using the Cartesian sign convention. In a spherical mirror, the distance between the object and the pole of the mirror is called the object distance. It is represented by the letter U, that is small u. The distance between the image and the pole of the mirror is called the image distance. It is represented by the letter small v. The distance between the principal focus and the pole of the mirror is called the focal length, represented by small f. The mirror formula can be expressed as follows. 1 upon v plus 1 upon u is equal to 1 upon f, where u is the object distance, v is the image distance, f is the focal length. It is given by f is equal to capital R upon 2, where capital R is the radius of curvature of the spherical mirror. The above formula is valid under all situations for all types of spherical mirrors, that is concave and convex, and for all object positions. Magnification due to spherical mirrors. The magnification due to a spherical mirror is given by the ratio of the height of the image h2 to the height of the object h1. This tells us how large the image is as compared to the object. Magnification, represented by capital M, is equal to the height of the image upon the height of the object, and that is equal to h2 upon h1. From this it can be shown that capital M, which is magnification, is equal to minus v upon u, that is minus the image distance upon the object distance. As the object is always kept above the principal axis, its height is always taken to be positive. For virtual images, the height is positive, while for real images, it is negative. As the object is kept on the left of the mirror, its distance u is always negative. Let us solve this numerical. An object of height 7 centimeters is kept at a distance of 25 centimeters in front of a concave mirror. The focal length of the mirror is 15 centimeters. At what distance from the mirror should a screen be kept so as to get a clear image? What will be the size and nature of the image? Our solution will be given h is equal to 7 centimeters, u is equal to minus 25 centimeters, and f is equal to minus 15 centimeters. The object distance will be negative in a concave mirror, and the focal length is always negative in a concave mirror. The distance of the screen from the mirror so as to obtain a clear image is taken as small v. Using the mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. Therefore, 1 upon v is equal to 1 upon minus 15 minus 1 upon minus 25. On solving, we get 1 upon v is equal to minus 2 upon 75, and therefore v is equal to minus 75 upon 2. Therefore, v is equal to minus 37.5 centimeters. Therefore, the screen should be kept at a distance of 37.5 centimeters from the mirror. After using the magnification formula, we get m is equal to h2 upon h1, which is equal to minus v upon u, and therefore h2 is equal to minus h1 into v upon u. That is, h2 is equal to minus 37 upon 5 upon minus 25 into 7, and we get h2 is equal to minus 10.5 centimeters. Therefore, the size of the image is 10.5 centimeters, and the negative sign indicates that the image is inverted and real.